Good morning and welcome everyone to our live event. Thanks for joining us today. Hopefully our last presentation really ignited your interest in industrial combustion performance. And we want to continue that discussion today. So over the next few minutes, we want to talk about the difference between I think and I know.
It's important to note that it doesn't matter the size of the operation nor the size of the furnace. Everything we're going to talk about can be applied to customers in big steel and aluminum, captive and commercial heat treating, and primary metals processing. And one thing that they all have in common is that most of their products go through a furnace at least once, whether that's an open fire or radiant tube furnace, or a batch furnace or continuous furnace. So before we jump into it, let's do a quick recap. In our last live event, we discussed the relationship between furnace performance and business performance, especially when everything you produce goes through a furnace. So fundamentally, furnace performance equals business performance. And additionally, we reviewed that combustion is simply chemistry. And because of that, there's a right way to run it. And when you don't run that right way, it can cost your business a lot of money.
So if you missed that video, check out the link in the comments section, or you can go to our website. And with that, let's get to our topic for today. Do you think your combustion is running efficiently, or do you know that it is? And really, the only way to answer that question definitively is with data. And when we know with data, it's going to positively impact your business performance.
Yeah, and PS Energy's been on many furnaces throughout the country, from small heat treat to large soaking pits. We've been on massive galv and annealing lines, and the story's always the same. Simply tuning your furnace once or even twice a year just isn't enough. These furnaces are operating at very high temperatures, often in challenging environments, and they're constantly changing and degrading.
That's right. So let's take a look at some data. We're going to review several graphs for a couple of different furnaces, and all the graphs are going to show combustion performance before and after tuning for a specific furnace over consecutive dates. Across the bottom, the x-axis, you're going to see the zone and burner number. Along the y-axis, the vertical axis, is going to be the measurement of percent excess oxygen in the exhaust. And recall from our last live event, excess oxygen in the exhaust is really a great indicator of combustion performance. The green dotted lines are going to mark the industry standard ideal range, which is that 2.8 to 3.2%. And the red dotted lines, those are really performance limits at 2% and 4%. And if you get below 2%, you're going to be making soot and emissions and reducing your heat output. If you get above 4%, again, you're going to be significantly reducing your heat output for every BTU that you're burning. The red data points on all of the graphs are going to be the initial measurements. This is how the PS Energy service team found the furnace when our team arrived. The blue data points are going to be the final oxygen readings in the exhaust, and that's when we were finished tuning. So let's take a look at this data this is a very large continuous annealing line. This furnace is 7 stories tall with 220 burners. And we'll step through the tunings starting here with August of 2018 and all the way to the last tuning we did in June of 2022.
And just note, we don't expect you to read every data point. Just simply notice that when we arrive, almost none of the initial burner readings shown by the red dots are in the optimal zone between the green lines. And when the PS Energy team leaves, all of the burners are performing properly, and this pattern repeats over and over. So occasionally you will see some stray burners that don't align, and that's just because there may be a component failure on that particular burner that will not allow us to adjust it. And as you can see, it's the same year after year. The furnace is left with combustion running optimally when it is tuned, and when we return, it's way out. Remember, those dots at 10% and above are delivering less than 50% of the energy to your products. So you're paying for the same amount of gas, but only getting 50% of the heat output.
Right. And as we step through, here's November of 20, same story. On to August of 21, again, the same. And lastly, June of 2022. So even after regular tunings over 5 years, when we arrive, most of the burners are out of tune, and really many to very extreme levels.
So that was looking at a very large annealing line in steel, similar to the one pictured on the left. Again, size and industry does not matter. because we've seen this over and over again on different furnaces throughout the country. This is purely about combustion performance over time. So now let's step through a smaller 44 burner furnace in an aluminum application starting in October of 2019.
And what you're going to see is fundamentally the same, right? When we arrive, the burners are not in tune. They're outside of that ideal zone. And when we leave, they are in tune. Now, this one's not as far out, but still enough to reduce the energy that's getting to the product and likely cause temperature uniformity issues.
Here you can see that over 60% of the burners are below 1%, which means that furnace is running very rich, getting soot in the tubes, so the tubes are clogging with carbon and giving up over 20% of the energy.
And this has really been the current state of maintaining combustion efficiency. Having an outside service team, maybe like PS Energy, or maybe an inside team, get on the furnace once or twice a year for a scheduled tuning event, and then you think the system's running efficiently between those tuning events.
And this is just outdated. Tunings may be scheduled, but combustion changes do not operate on a fixed schedule.
That's right. So without data, we really don't know when the drift in combustion performance happened. And I mean, these inefficiencies could have started any time during the 6-month or 1-year period between those tunings.
So often the initial response that we get when we present this data is that can't be us, our furnace is smaller or bigger, or we're in a different type of process, and it truly doesn't matter. We can show this data on many, many furnaces, and the story's always the same. Unless you're monitoring combustion regularly, you only think you're running optimally.
And today, you have the ability to know.
So the good news is that there is equipment that can be retrofit onto your existing combustion system that will allow your business to monitor combustion performance in real time. So PS Energy's combustion monitoring and alerting system is modern, highly technical, but yet very affordable. CMA easily retrofits to existing open fire or radiant tube burner systems and provides you the data to know that you're running optimally. So adjusting the air and fuel ratios on most systems is very straightforward. And with the help of our service engineers, it can easily be completed in minutes with your existing staff. Making the adjustments is not the difficult part, but knowing what adjustments to make is. And that's exactly why we developed CMA. So you might be wondering what the system provides. So let's take a look at an example dashboard.
And again, the size of the furnace doesn't matter, right? For ease of viewing, let's take a look at this 4-burner open fire system. And across the top, you're seeing the fire rate on the left side of each burner and the air to fuel ratio per burner across the top. This is just a snapshot of the data, but that data is being captured and recorded in real time. Below those, you can see graphs over time, again, of both data sets as well. So this dashboard is used to make real-time decisions and necessary adjustments on burners, as well as looking at the data over time, looking for trends in the data. And the historical data is saved on the system and can be accessed as far back as system installation. Now, this is super powerful data. Knowing that combustion is running well gives you really a firm foundation from which to make decisions and actually troubleshoot. In fact, we have a CMA customer that called our service team saying, hey, we're not making temperature in the first zone. We were able to pull up our data from our offices here and review with them in real time. And what we found was that combustion was actually running very well in that zone. We had the data to know that. So combustion was not the problem. With that data in hand, we were able to work with them and walk through the troubleshooting and started talking about the thermocouple and asked them to go check it. Sure enough, the thermocouple was bad. They replaced it, and within minutes, that problem was solved. Now, without the data showing that combustion was not the problem, they would have chased that under temp problem for some time. So to wrap up, you watch a lot of stuff in your process. Our question is, why don't you monitor the first step in the process? And that's making the heat. Combustion performance is not about, well, the furnace is hot or the burner flame looks right, or this is how we've always run it. Nor is it really, I think we're running well.
Combustion monitoring is critical to furnace and business performance, and we really don't accept, I think, in any other critical situations. So why would we accept it in industrial combustion when safety, quality, delivery, and business performance are all on the line?
So don't think, know. And with that, we'll take a look at any questions if there are any. You can always reach out to us directly. And if you see value in having the data to know your combustion's running well, or if you think you're having combustion issues, reach out to the PS Energy team. We can schedule a live demo of CMA. We can do a furnace evaluation at your facility. Take a look, keep an eye out for our next live event, and join us as we keep the fire burning on combustion performance and its impact on your business. Thanks for joining us today.
Thanks, everyone.